this tutorial I'll show you how to create a dynamic inventory in Unity 3D by using the Unity 4.6 UI system. And as you can see here, I've included a health bar in the top right corner here, and that's only for demonstration purposes because I've chosen to pick up some mana potions and some health potions, and these health potions will make me regen my health whenever I use them from my inventory. If you're interested in the health bar tutorial, it's available in the video description below, or you can find it by clicking the notation here on the screen. Okay, so I have chosen to add items to my inventory in two different ways. Some items are stackable and some items are non-stackable. And for demonstration purposes, I've chosen to create my mana potions as stackable items. So whenever I pick up a mana potion by entering the blue box here, you can see that it keeps stacking on itself, and I have chosen to make the maximum amount of stacks 10. So now there is 10, and whenever I pick one more up, it creates a new stack of items. I've chosen to make the health potion non-stackable, so whenever I take a health potion, it takes a new slot up every time because they are not stackable. These items can be used in different ways. You can actually click an item with the first mouse button to move it to another position in the inventory. You can click an empty slot, or you can click a slot where there is already some other items. When you click a slot with an item, it selects that item and it shows like that item you just selected in a hover icon, so you can see whatever you selected. And that item you selected grays out a little bit so you can see what slot you took it from. So if you click inside the inventory and click on another slot, it places the item in that slot. But if you click on an item and clicks outside the inventory, it deletes the item. Okay. Other than that, if you right click on an item, it will use the item for you. As you can see here, it's written down here, mana potion used. That's because I don't have a mana bar right now, so the only thing I'm doing is to write debug.log mana potion used. If I, on the other hand, would use a health potion by right clicking on it, you'll see that my health goes up by 10 every time I use a health potion. See, I can pick up some more so I can get full health. Yes. So now I have full health because I used my health potions. Other than that, I have chosen to make the inventory a little dynamic, so we'll be able to decide what size this inventory should be. So if I go to my script here, as you can see out here on the side, I have some different options. I have how many rows my inventory should be and how many slots. So for example, now I want my inventory to be 30 slots, and I want it to be in 5 rows, but if I said it should be 3 rows instead. And here you can choose the padding between the slots in the inventory, and here you can choose like the size of each slot. So this slot size basically scales the inventory. If I make it bigger, the whole inventory will get bigger. Let's see, now I changed it from 5 rows to 3 rows. If I open it up again, you'll see that my inventory only has 3 rows now instead of having 5 rows. So it's longer than before. Yes, and that's basically what we are going to do in this inventory. And again, if you're interested in the health bar tutorial, click the link in the description below. Before we can start coding, we need to add our sprites to the game. You can either use my sprites by downloading my project from the link below the video, or you can just create your own sprites to find something online. I have chosen to base my inventory system on 5 different kinds of sprites. There is the background sprite of the inventory that holds square box that encapsulates the inventory. Then we have the slots on the inventory, and these slots has a selected icon and a non-selected icon. And then we have for each item we need to put in the inventory, we have an icon for being selected and an icon for not being selected. So every time you create a new item you want to pick up in your game, you need to create an item for the inventory where it's selected and when it's not selected. So first of all, we need to add these sprites to the game, or to Unity project, and you can either do that by dragging your own sprites into the inventory, or downloading my package and double clicking on the inventory package. Whenever you double click on that sprite package I've included, you can click import, and then it imports the inventory here, and you have a a folder called sprites where there's a health potion where it's not selected and health where it's selected, and the same goes for the mana potion. And then we have the background of the inventory, and we have our slot sprite when it's not selected, and our slot sprite when it's highlighted or selected. So the first thing we need to make is the background of the inventory, and the background basically consists of an image. So if you click create, go to UI, and then go to the image and click there, you'll see that an image has been added to your scene. And besides the image, there's been added a canvas and an event system. And the reason that this canvas has been added is because whenever you create a new UI element and there isn't a canvas in the scene, then a canvas will be created for you. If we would create another UI element, like a text, it would also automatically be added to the new canvas here. The reason that it creates a canvas is because every single UI element needs to be a child object of a canvas to be rendered. So if I would take this image and pull it outside my canvas here, you'll see that it becomes invisible because it's not a child element of a canvas anymore. So to make it visible again, I'll just take it and drag it back into the canvas. Okay, so the first thing we need to do is to add the correct image. We can do that by dragging the image into the sprite box here, or we can click the radio button. So select your image, click the radio button, and then scroll down until you find your background of your inventory. When you have added that, you should be able to see that the inventory is shown, like the background of the inventory is shown in your game window or in your scene. Don't mind now that it doesn't look perfect as perfect as it should be, because we'll fix that during further into the tutorial, and we'll fix it through code. Okay, so this image here is going to be the inventory itself basically. So click on the image, press F2 or click up here and rename the image to inventory. When you have renamed it to inventory, we need to do a few more fixes. We need to make sure that the inventory is acting as we want it on every single resolution. For example, if we place our inventory very close to the edges here, as you can see, and we would play our game, the inventory will be moved away, because if we do it like this, you'll see that the distance between the top and the distance between the side is way bigger than it was out here when we placed it. And the reason for that is because we have these anchors here. Whenever you click an item inside a canvas, a UI element, it will have these 4 anchors, and these anchors are placed in the item's parent. So our inventory here has 4 anchors placed in the middle of the canvas, which is our inventory's parent. And the distance between these anchors and the corners of the sprite has to be the same no matter regardless of the resolution. So when they're placed here in the middle, the distance between the middle and the sprite here has to be the same all the time. So that's why it moves from the side up top corner here to the middle, because the distance changes. What you can do to fix this is to take all these anchors here. You can move all of them by clicking the middle of them, or you can move them individually by clicking one at a time. If you take them and put them in the top left corner together of the parent sprite, and place your inventory wherever you want it, well, then the distance between all the corners is going to be the same regardless of the resolution. So distance between the corners and the anchors is going to be the same. So if you play it, you'll see that our sprite is placed at the same position. So no matter what resolution your game is going to be run in, it will look the same. One more thing, we also want to take this this pivot point and put it in the top left corner of our sprite. This pivot point is going to be the 0.0 point of our sprite, and we don't want to calculate where to place our slots and everything by using the middle of the sprite, but we want to use the top left corner of the sprite. To be able to move these things around, you need to select this tool up here to the far right. If you have any other tool selected, you are not able to move the pivot point. So to move the pivot point, click the far right tool, and then you can move the pivot point around. The next thing we need to do is to create a slot prefab that we can use every time we need to create a new slot for our inventory. So just click on the Create button, go to UI, and add an image again. And just like we did with our inventory, we need to click on the radio button up here, and then find the basic sprite for the slot. And I'm just going to use this slot sprite. You don't have to worry about the size right now, because we will change the size accordingly to the size of the inventory through the code when we're going to create our inventory later. But take take the anchors here again and place them in the top left corner of the canvas, so that so all the slots will be placed at the right position. And as we did with our inventory background, also take the pivot point and place it in the top left corner of this of its own sprite. And that's basically what you have to do right now. Other than that, you need to rename the image to a slot, so just click on it, press F2 and write slot. And then we need to create a prefab of this slot. So basically you can go to your folder here, right click, press create, click folder and write prefab. And all these prefabs are used to creating or instantiating an object that you preset as settings. So we just want to set up our slot, and then we'll want the code to create as many slots as we want whenever we create our inventory. So take the slot, drag it to the prefab folder, and as you can see, it creates this little blue box here that we're going to use later in our code. We don't need this slot up here from our canvas, so just delete it, because now we have this preset slot here we're going to use later. When we've created our slot, we can start to make some code. And first of all, I want some order here, so I'm just going to click on my asset folder, right clicking, pressing create, and then finding a new folder and call it scripts. When I've created that script folder, just double click on it and then right click again inside your folder, click and create, and make like JavaScript or C# script. I'm gonna code in C#, but you can write Java if you want to. And then just write inventory. I'm also gonna include JavaScript versions of all scripts in the download link below. Double click on the inventory to open it up. And now we need to start writing our code. So the first thing we need to do is to create a rect transform, and the rect transform is basically what decides the position and size of the element in our game. So if we click on the inventory here, for example, you'll see there is a rect transform here, and this rect transform decides the width and the height and the positions of this element, and we want to change that from our code, so we need to create a rect transform that we can use. So if we jump back into our script here and write private rect transform and call it inventory rect. And the next thing we need to do is to create some variables we can save the width and the height of the inventory in. So we're going to make private float inventory width dot comma inventory height. So now we have created two variables to contain the width of the inventory and the height of the inventory. Other than that, we need to be able to set the amount of slots that has to be in the inventory and the amount of rows from outside the inspector. So we're going to make a public integer called slots and a public integer called rows, because we want to set this from our inspector, and that's why it's public. If this wasn't public, we wouldn't be able to set it from outside Unity here whenever we play our game. Yes. So next thing we need to do is to create the padding left and padding top, because whenever we place our slots, we might want to place them a little apart so they don't align totally. So maybe we want a little gap between them when we place them in the inventory. So make a public float and call it slot padding left and slot padding right. Sorry, not right, top. Other than that, we need to decide the size of the slots, and the size of these slots is basically the size of the whole inventory, because the bigger those inventory slots is, the bigger the whole inventory has to be. So public float slot size, and then we need to get our slot prefab, because we just created that prefab out there and we want to instantiate it from in here. So we make a public game object and call it the slot prefab. Other than that, we need some kind of collection to contain all our game objects, because whenever we have, let's say, 30 slots in our inventory, we need somewhere to contain all of them so that we can access them quickly whenever we click one of them. So just made a private list, just write list, and if you are using C#, okay, it's not there, let's see here. We just need to write up here in our namespaces like using system collections, just generic. And what this does is that it adds the namespace, or includes the namespace that contains the collection type of lists. So now I can write private list, and then I can write the type of objects our list needs to contain, and we want to contain game objects. I'm just gonna name it all slots. So this list is gonna contain every single slot our inventory has. So basically you call the list type, then you write the object type the list will contain, and then you give it a name and an identifier. Okay. Next thing we need to do is to create our inventory by using all this information we added up here. So we're gonna write private create private void, sorry. So create layout. And this function basically needs to set up all our inventory and place the slots in the right positions. And we want to call this function here from our start, because whenever we press play in Unity, then the start function is one of the first functions that are called. So just write create layout here. So we are sure that our create layout function here is going to be called at some point. Okay, so now I'm going to write the code that's going to place our slots onto the inventory. And this might be a little confusing, but I'll try to do my best to show some illustrations of what is going on and how it actually works, so that you'll understand it perfectly. If it's very hard to understand, then try to watch all the explanation through before you try to Google something to figure out how it works, because I'm going to do my best to explain it as clear as possible. So the first thing we need to do is to instantiate this list of slots, because before we can use this we need to instantiate it, and we do that by writing the name all slots equals new list. So now we have instantiated our list, and we have asked our computer to get some memory access so that we can save our objects in the memory. Next thing we need to do is to calculate the width of the inventory, and we basically calculate the width by taking the number of slots and rows and dividing them with each other. And I do that by saying, we know we have, for example, we have 10 slots. That's the number of slots. We want to have 2 rows in our inventory, and the size of each slot needs to be 25, for example. And in between each slot, then we want to have 2 pixels of padding between the slots, so that they don't stack right on each other. So the width of the inventory, the width of the whole inventory, is then calculated by taking the amount of slots divided by rows, multiplied by the size of the slots plus the slot padding left, and then adding the slot padding left again, so we get the padding in each side. And the inventory width is then basically 10 divided by 2 times 24 plus 25 plus 2 plus 2, and that equals 137. And if you look at the illustrations here below, you'll see that the first thing we do is to create size of 5, because that's the amount of slots divided by rows is 5. 10 divided by 2. Right now we don't have all the slots. The slots are only placed here to illustrate how the inventory would be sized according to them. So that's the first thing. We have that small inventory now. Next part of the line multiplies it by the slot size plus the slot padding lift, and that's 135. And if you look here, you will see that the padding is fine on the left side, but on the right side it doesn't. It only goes to the edge of the last slot here, and that doesn't look very good. And we want it to go a little further so that it has the same padding on each side. So the third thing we're going to do is to add 2 to the 135, so we get 137. And by doing that, we actually get this padding on both sides of the inventory. So it's encapsulated in the center of it. And that's how we create the correct size of the inventory, in the width at least. When we have created the width, we need to calculate the height of the inventory. And we do that exact same way, almost we're just going in the other direction. So we have the amount of slots, rows, we have the size of slots, and we have the slot padding top instead of left. So maybe you want to have bigger gap between them from the top, then you could change the slot padding from 2 to 4 or something, for example. Anyway, the height of the inventory is calculated by saying amount of rows, which is 2, multiplied by the size of the slots plus the slot padding top. And then we again, like we did before, to get the correct size, we add the slot padding top again. So the inventory height is 2 multiplied by 25 plus 2 again, which is 56. If we look here, we'll say first we take our rows, which are equal to 2. So we know we need to do this 2 times. And we multiply that by the size of the slots plus the slot padding top, which is 54. And as you can see, the edge of the bottom edge of each slot is hitting the edge of the inventory right now. And we want the inventory to be a little bigger than the edge of the slots. So we add 2 to it, so we get 56. And as we did before, you'll see that the inventory is bigger than the slots now, and now we have encapsulated our slots in the middle of the inventory, so we get this feeling that the inventory contains all our slots. If we jump back into Visual Studio, we can try to write the code that I just explained. So our inventory width is the first thing we want to calculate, and that's equals slots divided by rows times slot size plus slot padding lift plus slot padding lift. When we've done that, we can calculate the height of the inventory by writing inventory height equals rows times slot size plus slot padding top plus slot padding top. Okay, so now we have calculated our width and our height. The next thing we need to do is to get the inventory rect transform, because we made this up top here called inventory rect, and we need to make a reference to the rect transform on the inventory itself, and we can do that by saying inventory rect equals get component rect transform. So what this does is that it looks on the game object here, says, well, we are sitting on this game object and we need to get this rect transform, so we're going to make a reference to it. So whenever we need to change anything with the size or anything, we can write inventory rect dot something something to change the position and so on. So next thing we need to do is to place or resize the inventory, and we can do that by writing inventory rect dot set size with current anchors, and we need to tell this inventory rect set size with current anchors method that which what's called axis we want to change the size of, and the first one is rect transform dot axis dot horizontal, and we want to give the horizontal axis the inventory width we just calculated. And when we've done that, we need to do the exact same thing just for the vertical part. So that's the height. Okay. So here we have we set the size of the inventory's width, and we set the size of the inventory's height. So if we try to save this right now and jump back into Unity, and we can take this inventory script here and drag it from here to the inventory object here, or you can click add component, go to scripts, and find the inventory here. As you can see here, we have the different variables we set up here as public inside the script, and we'll be able to change them. Let's say we want 30 slots, and we want it in 3 rows, and the padding is 2 and 2, and the slot size is going to be 20. So if we play our game now, you'll see that the size of this inventory changes. As you can see, whenever we play it, it changes the size to whatever we want it to. Okay, but we need to add some more things. Now we need to add the slots itself. Right now we have just set up the size of the inventory. Now we need to put the slots on top of it. So before we start placing those slots on top of the inventory, I want to explain you what's going on. So first of all, we need to calculate the number of columns we need to place on the inventory. And to do that, we need the amount of slots, which is 10 in this example, and the amount of rows, which is 2. And then we need the position of the inventory, because we need to place the slots on top of the inventory regardless of where it's placed on the screen. Anyway, before we write the code, we need to understand that there is going to be 2 for loops. And a short explanation of a for loop is basically a loop that runs an X amount of times based on a condition. If you have no clue about for loops, then I suggest that you go and read up on for loops, because I'm going to use 2 for loops for this tutorial, and it's going to be a nested for loop. The first for loop, or the outermost for loop, is going to run through the rows of the inventory, and the inner for loop is going to be the X, and it's going to run through the columns of the inventory. So inside these for loops, we need to calculate the X and Y position of these slots we're going to place in the inventory. And the X position is calculated by taking the slot padding left multiplied by X plus 1, and X is the value of the innermost for loop, and then we're going to plus it with the slot size multiplied by X to get the correct position. The Y position is calculated by taking minus slot padding top, so the top padding between the slots, multiply that by Y, which is the outer loop, the value of the outer loop plus 1, minus the slot size multiplied by Y. So I have tried to put up some examples that explain this. So I've tried to make a breakdown of the 2 for loops to explain you what's really going on here. And on top here you can see we have our 2 for loops, which are defined with X and Y. And then we have our X and Y position, which is calculated inside the for loops by using the values of X and Y. So this example we start at position 0.0 because both X and Y are 0 when we start. The X position is calculated by taking the position of the inventory, which is 0 plus 2 multiplied by 0 plus 1, and 0 plus 1 because X is 0 at this point, plus 25 multiplied by 0, which is 0 because X is still 0, and that equals 2. So our first X position is 2. The Y position is calculated by taking again the position of the inventory, minus 2 multiplied by 0 plus 1, which is Y plus 1, minus 25 multiplied by 0, which is 0 because Y is still 0, and that equals minus 2. When we run through our first for loops, the position of the first slot is going to be 2 point minus 2, because the X position is 2 and the Y position is minus 2. We keep doing this, and next time we place a slot, our x position has increased from 0 to 1, or our x value has increased from 0 to 1. So our x position is calculated to 29, and our y position is still calculated to -2 because y haven't changed. If we keep doing this, we'll end up with 5 placed slots in the top row. And when we've done that, well, then the x value resets and the y value is increased. And the y value is increased means that our y position is now changed from the top row to the next row here. So the y position is 0 minus 2 multiplied by 1 plus 1 minus 25 multiplied by 1, which equals minus 29. So the sixth slot should be placed at position 2.-29. And we will keep doing this until we have filled out the whole inventory with slots. And that means that the last slot is placed at position 110.-29. I hope this makes sense. And now we can start writing our code that is gonna do all this for us. Okay, so let's jump back into the code. The first thing we need to calculate was the columns. So we're gonna make a variable called columns, and it's gonna be equal to slots divided by rows. Then we're gonna create our 2 for loops. First for loop is gonna be y, and it's gonna run through the rows. The inner nested for loop is gonna be named x, and it's gonna run through the columns. So this for loop runs through all rows, and this for loop runs through every single column. After that, we can start creating a new slot to place in our inventory. So the first thing we need to do is to create a new slot, and that's a game object, new slot. We're going to be equal to instantiate, and instantiate is used to create a new game object in our game, and we're going to create a new game object, which is our slot prefab. That prefab we created before in our editor. So that's the prefab we have up here, which is a public prefab. So we add it and we tell it to instantiate here. And we need to cast it to a game object so that we can access it later. So you just put the parentheses here and then write game object inside, which means that we cast this Unity object into a game object. When we've done that, we need to get the transform of this slot so that we can move it around and place it in the right position. And as I showed you before, the rect transform is what we need to manipulate with to place the slot wherever we want it. So rect transform, we're going to call it slot rect, and it's going to be equal to new slot dot get component rect transform. So what this does is that we instantiate a new game object from the prefab we added, and we save it in this variable called new slot. We've done that, we create a new rect transform, and we make this rect transform refer to the rect transform setting on our slot prefab. So if we jump into Unity and go to prefabs slot, then this slot has a rect transform on it, and that's the one we're actually grabbing on that last line of code we wrote. So we are grabbing the rect transform here so that we can change it later. Other than that, we also want to change the name of the game object. So we're going to write new slot.name equals slot. When we've done that, we need to set the slot's parent. And the reason that we need to set the slot's parent is that whenever we instantiate something, it might not be a child object of a canvas. And as you remember from before, that every single UI element needs to be a child object of a canvas. So if we would just go to our game and take the slot and instantiate it here, you'll see that it's not visible in our game because the slot here is not a child element of the canvas. If I put it inside here, you'll see that it becomes visible because it's a child element of canvas. And that's exactly what we need to do in our code. We need to make sure that the canvas is a parent element of parent object of our slot object. So if we go in here, say new slot dot transform dot set parent, and our parent needs to be this dot parent, this dot transform, sorry, dot parent. Yes. So what I've done now is that when I instantiate a slot, I say that my parent, the slot's parent, is going to be this, the inventory's parent, and the inventory's parent is the canvas. So this slot is automatically a child of the canvas object. Okay. So when we have instantiated somewhere in our game world and put the parent, then we need to set the position. And the position is set by saying slot rect, because we made a reference to that before, that local position equals, well, inventory rect dot local position. This is the code I showed you inside the for loops before on the explanation. Local position plus new vector 3 slot padding, padding lift multiplied by x, which is this for loop here, so it's 0 the first time it runs, plus 1 plus the slot size multiplied by x, which is still 0, and then we need the y position, and the y position is, make a comma and write minus slot padding top multiplied by y plus 1. And the reason that we withdraw the top is because we're going downwards on our, when we place them in the top first, and then we place the next one underneath, so we are minusing our top padding instead of adding it, so we put it in the right direction. Plus 1 minus slot size multiplied by y, then we need some parentheses here. Yes. So basically, if you understand what happened before when I was explaining these two for loops, is basically what's happened here is that we actually put the slot position in the correct, the slot's position as the correct value here by taking the amount of rows and the amount of columns and taking the x and y value of that and placing it, and then we're placing it here on this line of code basically. If you download the tutorial or if you download the project, then you'll also be able to see the comments. I'm going to comment everything in that project. Anyway, so now we have set up our position. Then we need to set the size of it, and the size is basically going to be slot rect dot set size with current anchors, and it's going to be rect transform dot axis dot horizontal, and the slot size, because we already set that before when we created our slots outside in the inspector. And we're going to do the exact same thing for the vertical. Other than that, we also need to add our slot to our list of slots so that we can have an easy access to them. So remember, we created this list here called all slots, and basically we need to add this new slot to the all slots list, and we do that by saying all slots dot add, and then we tell it that we need to add new slot. So now we have added it to our collection here of slots. So that's basically it for now. So let's try to save and go to Unity here, and let's see, we have our inventory. We need to add the slot prefab here, so click on your inventory, then drag the slot prefab out here on the empty spot here. Let's see, we have 30 slots, we need 5 rows, let's say that. The padding is 2 and the slot size is 20. Let's try to run and see what happens. And as you can see, all the slots have been placed fine on top of the inventory now. But let's see, if we change the size, see that it actually moves around with the screen size. But one thing we might want to change is that it's the canvas's setup. If you click on the canvas here, you'll see that the canvas scale here is going to be constant pixel size. And sometimes you might want to put it as scale with screen size, so that the inventory has the same size on the screen no matter what kind of resolution you're going to run. So if you run it on a mobile phone, it's going to have the same aspect ratio as if you ran it on a computer screen. Problem with this is if we run it here, you'll see that the objects are placed a little wrong here according to the size, and the more I change this, the weirder some of them are gonna look. So we are gonna make a little script that adds this, that changes this for us, because if I put constant pixel size on, run it, and then I change scale with screen size after I have run my game, well, then it actually looks kind of okay. Then everything is placed exactly where I want it to, even though my setting is scaled with screen size. So we're going to make a script that actually does this for us. So go to your script folder, right click, press create, C# script, and then called handle canvas, for example. This handle canvas script is just going to be dragged onto your canvas. So you take the script and drag it up onto your canvas and click on it to make sure that handle canvas script is attached to the canvas object. This script is a very small script, so if you double click on it and make a private canvas scalar, and if it's not there, then you can right click on it, click resolve, and use Unity engine.ui, or you can just write up here, you can just write using Unity engine.ui up here, and then canvas scalar namespace is included, so you can use the canvas scalar and just call it scalar. I'm going to zoom in so you can see it, so just call it scalar here. When you've done that, just jump to the start function here and write scalar equals get component canvas scalar. And then write scalar dot UI scale mode equals canvas scalar dot scale mode dot scale with screen size. Sorry, just need this one. Yes, and then you can basically delete update. So now you have a reference to the canvas scalar, and then you change the UI scale mode to scale with screen size after you have created your game. So if you save this, go back into Unity, click on the canvas scalar, and look here, it's like constant pixel size. When I start my game, it's going to switch this one to a scale with screen size, and as you can see, it works perfectly with the scale here. Actually, if you want to, you can click on your inventory and then click on the slot size and then change it to 50, for example, if you want it to be bigger. So if you change that to 50 and run your game again, you'll see that the inventory is way bigger now. So we also want some interaction whenever we mouse over one of the slots. So if we go to inventory, prefabs, slot, we can see that we have an image here, and we need to add one more thing to this slot. For example, we want it to be interactable. So if you click on add component, go to UI, and then you should find something called a button. And if you click on the button, you'll see that there's a button added here. And we want to change the sprite whenever our mouse hovers the image. So if you click here on the transition type here and click sprite swap, then you'll see that it has a target graphics, it has a highlight sprite, press sprite, and a disabled sprite. And we want to change this highlighted sprite from the standard sprite into the different sprite that is called the highlight sprite we have. So if we click on the highlight sprite here on the little radio button and then scroll down to slot sprite highlighted or whatever yours is named, click on that, and then we want the press sprite to be the standard sprite, so when we press it, it goes back to the original one. It's just use slot sprite here, and disable sprite is not necessary to set. So if we run our game again, you'll see that whenever you mouse over these sprites or these slots, now you'll be able to see that it's marked blue instead of yellow. If you click it, you'll see that you get like an interaction here, that it goes from blue to yellow. So now we need to create a script that has to be applied to every single item in our game, so that we can pick up some different items, for example some wood or like a mana potion or something. So go to your scripts folder, right click, press create, and then click script, C# script or Java or whatever, and then call it item. So this script is going to be applied to every single item in our game. So double click on the item. Just going to zoom in so you can see something here. And then we need to create an item type, and we do that by clicking up here outside the class space here and write public enum. And if you don't know about enumerations, then go and read up on them. Basically an enum is like a way of defining our own type. So we're going to write item type here, open brackets, and write mana, for example, and health. So we have an item of type mana and a type of health, and those two are gonna be mana potion and health potion, and then you make a semicolon after. So now we have defined a data type basically of the type item type. So we go back into our class scope here, inside the scope, and we write public item type, and we call it type. So this is the current type of this item. Go down under here and we write public sprite, because every single item needs some kind of sprite to go in the inventory. So whenever I pick up a mana potion, I need some kind of sprite to show in my inventory. So we're gonna call this sprite neutral. This is the standard sprite, and then we're gonna be public sprite, sprite highlighted. So we have a neutral sprite and we have a highlight sprite. And as you saw before, when I add the sprites, we have these two exact sprites for every single item. And as I told you before, we need some items to be able to stack and some items we don't want to be able to stack. And we just need to make a public integer here called max size. So this size decides how many times an item can stack on itself. So if a mana potion has this size set to 2, well then it's only stackable by 2. But if it has a size set to like 100, well then it's stackable by 100. And if 0, well then it's not stackable and it needs to be placed in another slot if it's added. Okay, so that's basically it for now. We are gonna come back to this. Actually, let's just add the use method now. So delete your start and your update, and then go and write public void use, because then we might as well just finish this class now and then not come back to it. And then we're gonna make a switch. So you write switch, and this switch is a flow control statement, which means that it can switch on a variable, and then a condition based on this condition in here, or that variable in here, the state of this variable, the code down here is going to be executed. So if we write switch on type, what did I call it? Yeah, type. I'm going to do it again. Switch on type here. Yes. Then it's going to set it up like this. If you don't have Visual Studio, then you can't do it like this. Then you have to write it up yourself. If you want to do it the easy way, you can write switch, double tap, and then write type, which is the variable here, and then press enter. Because this variable is item type and it's type, and then it makes a case for mana and a case of health, because we made mana and health up here. And then just delete the default case. Okay. So basically, we don't want to do anything right now. We just want to write debug.log. I just used a mana potion. Down here we're gonna write debug.log. I just used a health potion. So basically it looks at this variable called type. If it's mana, well then it's gonna write debug.log. I just use mana potion. If it's a health, well then it's gonna do debug.log. I use the health potion. So whenever the use method here is called on an item, well then it's gonna use it. Here for example it would be adding some mana to the player and adding some health to the player, but for this tutorial I'm just gonna write something to the console because I'm not gonna add health bar or anything. So this class is done, so let's close it down. Go back into Unity. When we're back in the editor, you can start adding some objects because we will soon need to test if we can pick up our objects and show them in the inventory. So let's start by adding our player. So click on the create, go to 3D objects and then click cube. And this cube is going to be named player. Just click on it and name player. And we need to place this cube inside the camera's view. So I need to go a little to the left. And then I need to go down a little, make it a little bigger. It should be inside the view. There it is, yes. Okay, so if you have some problems finding view, click on the camera's position here and see that it's in 0, 1, -10. Then place it there and then you can move it a little around. Anyway, I'm gonna make my cube a little bigger, I think 15 in all directions. Yes, okay. When you've added your player, then we can create a ground. Just right click on your player, press duplicate, then pull it a little down, pick the stretch tool, and then we're gonna make like a floor here from that cube. Yes. When you've added the floor, just click on it and rename it to floor. Then we also need to have some things we can pick up, so duplicate your player again, rename it to mana, duplicate mana and rename it to health. We've done that, and just take the two objects and then just place them close to the ground. Anywhere you want them, just get like a setup like this. Okay. We also need some light so we can see something, so go to game object, go to light and click on directional light. Yes, as you can see, then we can see something now. Okay, next thing we need to do is to give the player some gravity. So click on your player, click add component, go to physics, click rigid body, and then make sure that you can play your game, and the player is going to fall to the ground here slowly. Yes, and land here on the floor. Okay, and we can move our player around crazy here. Yes. Next thing we need to do is to differ the, what's it called, the mana from the health visually. Just gonna place this accordingly. Yes. So go to your inventory folder here, right click, create, make a new folder, and call it materials. Open the materials folder and right click and create a material, call it mana. Select the color here, for example blue, and then create a new one called also material and called health, and then change the color to red, for example, and then drag the health to the health and the mana material to the mana. So we have two different colors. Okay, so now the scene is basically set up. We can place our player a little closer to the ground if you want to. Here we go. Yes. When the materials has been added, we need to add the scripts to the two objects. So if we click on the mana, click add component, go to scripts, then click item, you'll see that the item script has been added. And as you can see, the type is already mana, and we can also select health, and that's because we made that public enumeration in our script. So just leave it at mana. As you can see, we have a sprite neutral and a sprite highlighted. And the sprite neutral should be, if you click here, you should find the mana potion neutral. And the sprite highlighted should be the sprite mana potion highlighted, or selected, or whatever I called it. Yes. Max size, let's say that the mana potions can stack 5 times. Same goes for the health. Click on the health, go to add component, click the scripts, go to the item, and select at the type health. Done that, you click sprite neutral, the radio button, find the health one, sprite highlighted, click the radio button, find the health selected, and max stack size is 0, for example, so it can't stack on itself. When we've done that, we need to add some functionality to our slot, because as you can see, some of the items are stackable, for example our mana potion. So we need to change a little, or add some functionality to our slot prefab. So we do that by taking the slot and dragging it into our scene. And I have one then already. Let's just, if you don't have a slot in the scene already, then take the slot prefab and drag it into your scene. When you've done that, we need to add a text object, and you don't need to add it to the canvas, just add it to the slot. So click create, UI, press text, and then a text object should be added to your canvas. Just take that text object and drag it onto the slot object, press F2 and rename it stacks. This text object is going to tell us how many stacks of an item we have. So if we have 2 or more stacks, there's going to be written a number on top of the icon, and this is this text. So if you click on the stacks icon after you've taken it from the canvas and dragged it onto the slot, then then go to the text and delete it, because we're going to change that from our code later. The font is, you can pick whatever font you want. I'm just going to go with standard Arial. Font style, bold. I'm not going to do anything here. I'm going to align it to the right. You can align it in the middle if you want to, or something else. I'm going to align it in the bottom, so it's going to be in the right and the bottom of the icon. When you've done that, you click the best fit here, and then you can set a minimum and a max size, and we're also going to do that from our scripts. So basically, let's say 15 and 15 is standard if we don't set it. So the color of the text, maybe you have some different colored inventory where you need to use another color than white. I'm going to use white as the text on top of my icons. Material is not something we should do anything about. Okay. So now we have set up the properties of this text, and the next thing we need to do is to place the text correctly. So click on the slot, the stacks here, drag it on top of the slot icon, and make sure that it has the exact same size as the slot icon. Then you select your far right tool here and take the pivot point, place it in the top left corner, and then you take the anchors here and place them in the top left corner as well. When you've done that, you're done setting up your slot for now. So just take the slot, drag it back onto your prefab, and delete the slot from your scene. So now that you have done that, we can start writing some code for our slot object. So go to the script folder, right click, press create, and then go to C# script or JavaScript, and then write slot, and then double click to open it. So the first thing we need to do in this script is to add a stack of items, and we can do that by including the system.collections.generics namespace, because we need to get the collection called a stack, and we write that by writing private stack item, because it needs to contain items, and then the name is called items. So this stack is basically going to contain every single item that the slot contains, for example a stack of potions. So some of you might be wondering what a stack is. A stack is a type of collection in C# and it's instantiated the exact same way as you instantiate a list. So whenever you instantiate a stack, you have to tell it what kind of objects it will contain, for example item, and then you have to give it an identifier so that you can use it later in your code. This collection is called a stack because it works exactly like a stack, for example a stack of papers. So whenever you need to put a new item into your stack, you have to use the function called push, and this function takes in that object you want to add to the stack, and that object is going to be pushed to the bottom of the stack. When an item has been added to the stack, you can remove it again by using the pop method on the stack, and the pop method basically takes the top item or the top object in the stack and removes it and then returns it. So as you can see here, there is 2 potions inside our stack, and 1 was added first and 2 was added after. And as you can see, when I use items.pop, well, then it removes the second potion because that was the last potion we added to the stack. Because of this functionality, it's possible for us to use the last potion we actually added to the stack. So whenever we add lots of potions to the same slot, well, then we'll always use the last potion we added. If you want to check what's inside your stack without removing an item, you can actually use a method called peek. This method returns the top item without removing it from the stack. When the stack has been added, we need to create a reference to our text, and we can do that by writing public text. And if you can't find the text, it's because you need to include the namespace using Unity engine.ui, and we're just going to call this stack text txt. So now we can create a reference to our text so that we can manipulate it. We can add stacks to it, or we can remove stacks from it, or change the size and everything. Okay, so the next thing we need to do is to make a public sprite called slot empty, because we need a reference to a sprite when the slot is empty. Public sprite called slot highlight, and these 2 sprites are basically used whenever a slot has been occupied by an item and we need to reset it to the basic or standard sprites when it's empty. When that's done, we need to instantiate our items. So we write items equals new stack. Now we have instantiated our items, and when we've done that, we need to set up the text basically. So first of all, I'm going to make a rect transform called temp rect. Let's call it slot rect equals get component slot. Yes. And when I've done that, I need to, sorry, not slot, of course, rect transform. Yes. So now we have made a reference to the transform sitting on the slot. So this is the rect transform here. That's the one we have made a reference to. Yes. So then we need to make a reference, a new rect transform also. Call it text rect get component rect transform, and that's basically the transform sitting here on the stack. This transform up here so that we can change the size and everything on that. Okay, so when we're done that, we need to calculate the scale factor, and the scale factor is the factor that we need to scale our text with according to the size of each slot, because if we have a big slot, of course we need to make the text bigger then. And we can do that by saying, for example, the text should always be 60% size of the slot. So integer equals text scale. Text scale factor equals get component. Or actually we don't need get component, we can just say text actually slot rect dot size delta. It's not that one. Slot rect size delta dot x, and that's multiplied by 0.6 to get 60% of it. And then we need to cast it to an integer. Yes. The reason that we make this integer here is because we are trying to save it into an integer variable here, and this returns a double, so we need to cast it into an integer. So now we have calculated the scale factor of the text by taking the width, basically, of the slots rect and multiplying it by 0.60, so we get 60% of it. So the text will have the size, which is 60% of it. And then we can set the text rect dot set size with current anchors, and say that the rect transform dot axis dot vertical, for example, and we need to set that as slot rect dot size delta dot x, and we need to do the exact same thing for the horizontal, and that's just gonna be x, and this one up here of course gonna be y, sorry. So yeah, the vertical text rect size with current anchors, the vertical is of course gonna be y, and the horizontal is of course gonna be the x size. Okay, when I've done that, I can use the text scale factor to set the size of the text, minimum maximum size. So if I say text stack text, isn't that what I call this? There we go. Dot resize text max size, and that should be equal to the text scale factor. And stack dot resize text minimum size equal to text scale factor. Okay, so here I calculate the scale factor, and here I use it to set the maximum and minimum size of the text. So whenever we add or remove an item from the inventory, the effect slot needs to change its icon. For example, if we pick up a mana potion, then that slot we are going to put the mana potion in needs to have changed the icon from an empty slot to a mana potion. And to do that, we need to, if we go to the inspector here and look at the button script here, then you'll see that there is like target graphic, there is highlight sprite, pressed sprite, and a pressed sprite. And these are the sprites that we actually need to change from within our script. So we should actually make a function that can handle all this for us. And let's just make a private void and call it change sprite. And it needs to take two parameters, a sprite, which should be the neutral sprite, and then we need a sprite, which should be the highlight sprite. So whenever we call this function, we can tell the function that it needs to change the slot's neutral sprite and the highlight sprite to, for example, a health potion when it's highlighted and a health potion when it's not highlighted, or something else. So first of all, we need to set the standard sprite. So we're gonna write get component image, and then say that image sprite is neutral. So basically this line goes to the slot and goes to the image here, this image component, and takes this sprite and changes it to the standard sprite we want. When we've done that, we need to create a sprite state, because we want to change this sprite state here. This is a sprite state, so that we can change the highlighted state, press state, or the target graphic, for example. Okay, so if we go back into Visual Studio, we're gonna make a new sprite state called st equals new sprite state. We've done that. We need to set the state's highlighted sprite to the highlighted sprite we just gave in here, and we need to set the this, what's it called, press sprite equal to the neutral sprite we also added here. And when we've done that, we just need to add this state to the button. So we're gonna write get component button to get this button component here, so that we can change the sprites. And we're gonna say sprite state equals st, because we just created a new sprite state here, and we decided that the highlighted and neutral sprites should be used for highlight sprite and press sprite, and then we just added it to the button state, sprite state. So now whenever I call this one with 2 new sprites, it's going to change the state of this button or this slot. So now that we can change our sprites, we can actually start adding some items to our inventory. So let's under update here write public void add item, because this is the function that needs to be called every time we want to add an item to our inventory. And it needs to take a new item in, because we need to add the new item. So when we call add item, we're gonna give it that item we need to add to the inventory. And we just need to add the item to the stack here called items. So we're gonna write items that push, and then tell it we need to add this item here. When we've done that, we need to make sure that we write the text on the screen according to how many stacks we have on the slot. So if we only have one stack, we're not interested in writing the stack out to the screen, because we don't want lots of icons with a big 1 on it. It's only if there's 2 items on the same slot we want to write the number 2. So if items that count is greater than 1, well, then our text, stack text, the text equals items that count to string. Okay, so basically this checks, do we have more than one item in our stack? If we do have more than one item, we need to write the text. So we take the stack text, and we write the items that count, which is our stack, so the amount of items on our stack in this text, and we don't do to string because the count is an integer. So basically what we're doing is that we are taking our, go to our prefabs here and stack, basically we're taking this text object and we're writing how many items there is in this text field of the item. Okay. The next thing we need to do is to change the sprite. So when we add a new item, well, then we also need to change the sprite from empty to whatever item we just added. So we're gonna say change sprite item, because the item we gave up here, dot sprite neutral dot, and then we need to give the highlighted width, because we told it that it should give the neutral first and then the highlighted after, dot item dot sprite highlighted. And the reason that I can say item dot sprite neutral and item dot sprite highlighted is because we created our script here called item, and it has a neutral sprite on it and a highlighted sprite on it, and it's these two sprites that we're taking from the item script here and giving to our change sprite function. So basically if we go to the item, you can see that we have sprite neutral, sprite highlighted, and that's exactly what we are giving here, item.sprite neutral, item.sprite highlighted. So now whenever we add an item, we'll change the icon of the inventory slot to the picked up item. Now we have added the functionality to each slot so that it can contain an item, or so that we can actually add an item to it. Before we continue with the other scripts, we should just add one more thing that makes it easier for us to check if a slot is empty or not. That's a boolean, so we're going to write public bool in our fields called isEmpty. And this boolean is just going to get return items that count equal to 0. And what this does is that it makes a property so we can access the slot class, and then we can say slot.isEmpty and then check if the slot is empty, so it's available to put any item in it. If the count is 0, well, then the slot is empty because the item stack has 0 items in it. If the count is larger than 0, well, then it's going to return false because there is some item on it, and then we need to handle it a different way. Maybe check if we can stack an item on it, or if we need to find another slot to place our new item in. So that's it for the slot class right now. So let's go to the inventory class. So now we need to add some functionality to our inventory so that we can add the items to the slots in the inventory. And to do that, we need to add one field, and we also need to make a couple of functions so that we can add something to the inventory. So you need to consider that there is two different ways we can add an item to the inventory. We can find an empty slot and place an item in that, and we can find an item that's the same as we want to add to the inventory and stack that item we want to add with that other item in the inventory. So we are only going to add that function that places an item in an empty slot right now, because we're going to come back to stacking items later. So the first thing we want to do is to create a new to create a new field. There's a private integer called empty slots. And this field is basically going to keep track of how many empty slots we have in our inventory. So we can also always check up on this if we have the possibility to place our item in an empty slot. This empty slot is going to be equal to empty slot equal to slots, because we write in our Unity editor how many slots we want in the inventory, and this empty slot is going to be the exact same amount as that when we start, because our inventory is going to be empty whenever we start our game. After that, we need to add a couple of functions. We need to be able to place our item on an empty slot, and we can do that by creating a new function called private bool place empty. And this function is basically going to run through every single object in our slots collection. So it's going to run through that collection called all slots and check if every single object is empty. And if it finds an empty slot, well, then we're just going to place the item we want to place in the inventory there. So we also need to add an item here, and this is going to be the item we want to add to our inventory. So if we run around in our game and we find a weapon or something on the ground and we want to add it to our inventory, well, then we collide with it, and this is going to be that item here. So before we actually check if we can add anything, we need to make an if statement saying if empty slots is greater than 0, because there's no reason to check to try to add it to the inventory if we don't have any empty slots. So when we've done that, we can make it for each, and we're going to run through a collection of game objects, and every time we find an object, we're going to call it slot, and the collection that we're going to run through is going to be all slots. So we need to make a reference to the slot. We're going to slot temporary equals slot.getComponent slot. So what this does is that it creates a reference to the slot script on the slot we are looking at the moment. So if we say if the temporary is empty, because we just made that functionality before, so if the slot is empty, well, then we just found an empty slot and we can place our item in that slot. So we say temp.add item, and the item we want to add, which is this item up here from the parameter. And then we're going to say empty slots minus minus, because we're going to remove one empty slot now. And then return true, because we already added the item and there's no reason to keep looking for an empty slot. Outside this, we need to return false to signal that there weren't any empty items in the inventory. It wasn't possible to place this item in an empty slot. Okay. Then we need to create the function that our player, for example, actually needs in the inventory, because the player needs to have the inventory on him or something, and then he needs to call this function called add item on the inventory to try to add an item to the inventory. And we're just going to add some of the functionality right now. We're not going to add the stack functionality before we have tested that this works. So public bool add item, and it's going to be an item we want to add. So if item dot max stack size equals 1. So if the item we want to add has a max stack size of 1, well, then we need to place it in an empty slot because it's not stackable. If it was stackable, the max stack size would be greater than 1, and we would have to check the inventory for another item of the same type so that we could stack it with it if it's possible. And then we're just going to call place empty item. And then we're going to return true, and out here we're just going to return false. Okay, so now we have added that functionality so that we can take our inventory and add something. And now we need to go to our player script or create a player script so that we can run around in our game and pick up the items. So to do that, you need to jump back into the Unity editor, then go to your script folder, then right click on it, press create, then go to C# script and write player. And this is the script that needs to make our player move around and make sure that we pick up the items that we collide with. So just double click on the script to open your script editor. And then we need to add some movement functionality. So make a public float called speed. This one is going to be the player's movement speed. And we also need to make a reference to the inventory. So make a public inventory. And this is going to be the reference so that we can actually add items to our inventory. So the player is going to have its own inventory. Then we need to go to our update, or let's create a new function called private void handle movement. And this function is basically going to move the player around. So we need to make a translation because we want our player to move frame rate independent on each device it runs on. So we need to calculate the movement by taking the speed and multiplying it with the time, the delta time. So translate equals speed multiplied by time, the delta time. This makes it frame rate independent. So we can use this translation to move our player by saying transform the translate new vector free, and then we can tell it that we need to move on input that get axis horizontal multiplied by the translation we just made. This is the x-axis, and as the y-axis is 0 because we don't want to move straight upwards, and the z-axis is going to be input dot get axis vertical. It's going to be multiplied by translation. So shouldn't be anything tricky in that. That's just movement of the player, and then we need to call handle movement in the update. There we go. So now the handle movement is in place, but we also need to make the functionality that checks if we collide with an object we can pick up. So we're going to make private void on trigger enter, and it's going to take a collider. And this on trigger enter is going to check if that object we collide with. So every time we collide with an object, this on trigger enter is going to be called if it's a trigger we're colliding with. And we're going to make an if statement saying if the other the tag equals item. Well, if it equals item, well then we need to handle that and put it in the inventory, for example. And remember, if you write item here with a big I, capital I, well then you also need to make it with a capital I when you create your tag in a moment. So we're going to say inventory dot add item because we just made that function, and we're going to add the item from other dot get component item. Okay, so what we're doing here is that we collide with another object, and if that other object is tagged as item, well then it must have an item item script on it. So we jump into the if statement and add that script, that item, or get that item from the other object we just collided with and add it to our inventory. So we can save that, go back into Unity editor, And then we need to go to our mana, and we need to go to the tag here, write add tag, and write item as we did with capital letter in there. Then we know to click on mana again, click on the tag and tag it as item. Also need to go to health, click on the tag and add it as item. So now the health and the mana is tagged as items. And one more thing, if we look at the script here, you will see that this is called on trigger enter, which means that we need to collide with the trigger. So we need to click on mana and click the little is trigger box here, and the same goes for the health. So now they're both triggers. So besides that, we also need to go to take the player script here and drag it onto our player. Or we need to click add component, go to scripts, and then click on the player script here. Only do one of the things. So now the player has a script on it, and we need to say set the speed. Let's say we have 100 in speed, and then it also needs an inventory. So if we click on the inventory here, we can see that we have an inventory script on it, and we need to put that on the player so the player has a reference to the inventory. So just take the inventory here and drag it onto the player. So now it has a reference to this inventory we have in our game. Besides that, we also need to change a little in the prefab of the slot. If you click on the slot here and click on the slot prefab, well, then we need to give it a slot script, because before we created that script that should handle adding an item to each slot. So click on add component, go to scripts, find the slot script and click on it. And as you can see, it adds the script, and it has some public variables here we need to set. First of all, the stack text is the text that it needs to manipulate with whenever we add some stacks to it. So take the stack here and drag it onto the stack text so that it has a reference to this text here on the slot. Other than that, we need to add two sprites, an empty sprite and a highlight sprite for using whenever the slot is empty. So go to the sprites, find the slot sprite, drag it onto the empty spot, find the highlight sprite and drag it onto the highlight spot. Or you can click the radio buttons out here and find the sprites. So before we run the game, I want to check if everything is set up properly. If you click on the mana, you'll see that it has a max size of 5. Well, we need to put it at 1 because we're only handling items with the max size of 1. And the health also has a max size of 0, which is not good, so it needs to have a max size of 1. So click on both your mana and your health object and set the max size to 1 on both of them. So when you've done that, you can run the game. And then you can see your player can move around, and if we go into the health, we'll add some health potions to our inventory. We go into the mana, we'll get mana potions instead. As you can see, this works fine, and we can mix it up. So now we have the functionality to add one single item, but we also want to handle stacked items, so let's add that functionality as well. So let's jump back into our script so that we can add the stacked functionality. And the script that we need to look at is the slot script, because before we start playing around with the inventory script again, I want to add like a couple of properties that makes our life easier when we have to check if an item can stack upon itself. So let's make a public item. Here's like this property called current item, and this basically just returns the type of item that we have on our slot right now. So gonna get, and then it's gonna return items.peek, and the reason that I'm using peek instead of pop is because I only want to look at the item, I don't want to use it right now. Yes, and it just returns the top item on this item stack. Besides that, I also want to make a boolean that tells me if the slot is available for stacking. So it's just going to be bool is available, and it's basically just going to return the current item dot max size. If that one is larger than the items that count, well, then the slot is available. And if it's not available, then it's going to return a false, if the max size count is smaller than the current count. So if the current item max size is larger than the items that count, well, then the slot is available. Just gonna save this. So now we can start adding the functionality to our inventory. So if we jump back into our inventory and go to the add item function here, we can add the extra functionality that makes us able to stack our objects. So we're gonna make an else statement here, and we're gonna make it for each loop, and this for each loop is gonna look at all game objects, and every time we find a game object we're gonna call it slot, and it's gonna be looking through the all slots list here. And we need to check what slot we can actually stack an item on. So we need to get the slot temporary equals slot dot get component slot. Okay, so now we have made a little reference to the slot script on the slot object here, and this is the reference here we're gonna look at. So if temporary that is empty, and we want to see if it's not empty. So if we find a slot that that isn't empty, that is occupied, well, then we need to check if we can stack that item on it that we just picked up. For example, if we find a health potion, well, then we need to find another stack of health potions in our inventory, and this is basically what we're doing here. So if our temporary dot current item dot type equals item dot type, so we are comparing the item that occupies the slot we're looking at with the item that we want to add to our inventory here. This is what we're doing right here. If those two are equal to each other and temporary is available, that our slot is still stackable, that there is still free space on the stack, well, then we're gonna say temporary dot add items. Then we're gonna add the items to that slot, and then we're gonna say empty slots and reduce it by 1 and return true because we just added an item. So if this wasn't possible for us, well, then we need to handle if this wasn't possible, let's say that we ran through our whole inventory and we tried to place a stackable item on another stackable item and we didn't find any, well, then we need to add the item to an empty slot. So we're just gonna see if empty slots is larger than 0, well, then place empty item. So if it wasn't possible to stack it on another stack, well, then we're just gonna place it in an empty slot instead. Before we test it, I need to make one correction in the slot class. So just go to the slot class and see in the start function. Here I made one mistake by saving the same component to both the slot rect and the text rect. And if we do that, then the text is not going to be displayed correctly. So we actually need to get the stack text rect transform here. So we're going to write stack text dot get component rect transform here, and that's the one correction we just need to make, and then everything should be working as intended. So let's save again and go back into Unity, and then we should click on our mana and make sure that it has a max size of like 5, for example. So click on your mana. If you haven't set the size already, then put it at 5, for example, and then go to your health and set the size to 2 or something higher. I don't know what you want to try. So our health potion should be able to stack of 2 now, and the mana potion should be able to stack of 5. Let's give it a try. So if I open up my game, I can move my character around, go into the mana potion, health potion, sorry, pick one up more, there's 2 now, go in again, and it makes a new stack because it's only stacks of 2. So go into the mana potion, it should be able to stack 5 times, and if I go back here, it places the health potion on the empty stack here. So our stackable functionality works perfectly. So as of right now, our inventory doesn't have any real click functionality. The only functionality there is that I can mouse over stuff and I can click so it changes the sprite. But I want to be able to right click on the items to use them, and I want to be able to click on with the first mouse button so that I can swap places or put them in another slot here. And I'm going to do this in steps, so I'm going to start with the functionality that actually makes me use the items. And to do that, we need to jump into our script again, and we need to go to our slot script. And in this script, we have to add a new function called useItem. And it's just going to be a private function called returning void called useItem. And basically this function is just going to take the item that occupies the slot, and then it's just going to use it. So it's going to make an if statement first that says is empty. So if the slot isn't empty, so we're going to make an exclamation mark in front of it, well, then we can use the item, because if it isn't empty, there should be an item occupying the spot, and we can use it. So we're going to say items.pop, and I'm using pop here instead of peek because I want to remove the item from the stack, and because I'm using it. So item.pop removes the item from the stack. I'm going to click .use. So basically this line of code takes the top item from the stack and uses it. The next thing I'm going to do is to make a smart if statement. So basically when we use an item, we also need to update the text on the item. Let's say we have a health potion stack with 5 health potions on it, and we use one of the health potions. Well, then we need to write the number 4 on it instead of 5. And if it was a health potion stack with 2 potions on it, and we used 1 health potion, well, then we need to remove the number totally, because we don't want the number 1 written on a 1 stack item. So we can do that by writing text equals items.count larger than 1 question items.count to string, and then colon string.empty. So this is basically smart if statement or one-liner if statement. What happens here is like you say stack text.text equals one of these 2 statements depending on the condition here. So if items.count is larger than 1, well, then the text is going to be equal to items.count. So we're going to write a number here. If it's not larger than 1, if this one returns false, if for example we have 1 item left, well, then the text is going to be string.empty, so we're not going to write anything in our text. Besides that, we need to make if is empty again. So if we just removed an item and the stack is now empty, well, then we need to change the sprite to slot empty and slot highlight, because we just used the last health potion, for example, and we don't want a health potion to occupy an empty slot, so we're gonna put the sprites back to the standard sprite slot empty and slot highlight empty. So when we removed an item, for example, let's say we had a stack of health potion and we removed one, well, then we need to be able to reduce the number of empty slots, or sorry, increase the number of empty slots in our inventory. And we can do that by adding 1 to the number of empty slots here. So we need to access this empty slots from within our slot class. And what I want to do, I want to be able to say inventory dot and then empty slots, and then I would just want to add 1 by saying ++, for example. But right now I can't do that because I need to make this one available to other classes, like the access right now is private. So I can make a property so that I can access this one by right-clicking on it, refactor, and clicking encapsulate field, and clicking apply. So what this does is that it actually makes a property so that I can access it from other classes, like because it's public. So this is not enough yet, but we are getting there. So if you don't have your Visual Studio, well, then you can't right-click and press refactor. Well, then just write this code by yourself by writing public int empty slot and so on. So I still can't go in here and say inventory dot empty slot. And to make this available to be accessed on the class level like this, well, then we need to make this one static. So write private static and public static here. When you've done that, well, then you have made the variable static, which means there's only one instance of this variable, which means that you can actually say inventory dot empty slot plus plus. So it's actually called empty slot. I actually wanna go here and rename it to empty slots because it's more. So press F2 or right click and rename and call it empty slots. It's more like the name is better. Okay, so if you don't have Visual Studio, I don't know if you can rename in your ID, but either right click on it, refactor and rename, or press F2, because then it renames it all through the code. So now I have renamed it to empty slots. Go back here, you can see that it's also called empty slots here. So if I remove an item and the slot is now empty, well, then I need to increase the number of empty slots in my inventory. So the next thing we're going to do is that we're going to add some functionality so that we can actually use the items by right clicking, because right now everything is based on first mouse button click, because Unity as standard has chosen to make the first mouse button primarily click button for buttons and stuff. So we need to add some functionality so that we can right click on them. And to do that, we actually need to implement an interface. And we do that by going up here to the top of the class and then making a comma after mono behavior. And then we're going to write the name on the interface that we want to include. And the interface we want to include is called iPointer click handler. So if you get a squishy red line here, then just right click on it, click resolve, and click using Unity Engine event system. If you can't do this because of another IDE, well, then just write this line of code yourself using Unity Engine event system. It works exactly the same. Okay, so when you've done that, we need to implement the interface, and you can do that by right clicking on it, clicking implement interface, implement interface. When you've done that, then the interface has been implemented in the bottom of the script here, and you might as well just delete this exception here. And if you don't have Visual Studio and you can't implement like that, well, then just write this code yourself. Public void onPointer click pointer event data. So this onPointer click is called every time you click on your pointer, funny enough, and then this pointer event data is given in as a parameter. And this pointer event data actually contains data about which button we just pressed, so we can use it to check up on if we just clicked the first mouse button or second, for example. So we're going to write some code here that says if event data that button equals pointer event data button dot right. So this function is called when you click your pointer. So it says, hey, the pointer was clicked. Then it jumps down here and says, okay, which button did we actually click? If that button is equal to the right button, well, then we want to use the item, so we just write use item. And that's it. Now we actually added the functionality so that we can right click on an item. Okay, so let's jump back into Unity and check if everything works. If we open up our console here, let's just put it up here so I can see what's written. And then I pick up a couple of items here. And if I right click on this, written I use the health potion, and the health potion is gone. I can right click on this, I use the mana potion disappears, and it should just start stacking again if I'm using them. And as you can see, it works fine by right clicking on them. So now we have the right click functionality to use the items, and the next thing we need to do is to be able to pick up an item and then click on it with the first mouse button to move it to another slot, or to replace the two items by each other. So let's jump back into our code so that we can start writing some functionality here. So if we want to be able to swap the items around in our inventory, well, then we need to create a new function, because the function we already have that's called add item is not enough right now, because we need to move more items at the time. For example, we have a stack of mana potions and we want to replace that stack of mana potions with a stack of health potions. So instead of taking one item at a time, we should make a function that can actually take a whole stack and replace the stack on another slot. So we need to create a new function called public void add items instead of item, and it should take a stack as parameter, and the stack should contain items, and we're just going to call it item. So this parameter is basically just going to replace the items that are currently occupying the slot. So this dot items equals new stack, and we're just going to take items in here. So this line replaces the items that are currently occupying the slot with a new stack of items that we want to place on that slot. So when we've done that, we also need to update the text, and if I'm not mistaken, then we already wrote something in one of our functions here to replace the text with the correct line of code, the correct amount. So if we copy this line of code from the use item and paste it in our add items function here underneath here, and then we also need to replace the icon with the correct sprite. So we also need to take this change sprite function here and copy and paste it down here. So one more thing we need to do is to change the item with the current item. I think that's what it's called, yes. So here we replace the stack, here we write the correct text, and here we place the correct icon. Let's say we just place the stack of health potions on an item. Well, then this function is gonna take the correct sprite and place it on the slot so that it looks like a health potion. So when we've done that, we can actually jump into our inventory script, because the inventory is gonna have the responsibility of moving our items in our slots around. And to do that, we actually need to make two references, because we need to remember what stack or what slot we are moving from and what slot we are moving to, so we don't lose anything when we are swapping stuff around. So to create two references, just click somewhere in your fields up here, like private slot from to, and these two fields here are going to contain the slot we are moving something from and the slot we are moving something to. Then we also need to create a function, and this function should also be public, and we need to place it here. So public void move item is basically going to be used to move an item. It's going to take a game object called clicked. So this function has this parameter here called clicked, and clicked is that item or that slot we just clicked in our inventory. So we can actually check up on what we just clicked and check if we want to move something onto it or from it or whatever we want to do. So the first thing we're going to do in our move item function here is saying if from equals null. So if from equals null, well, then it's the first item we're clicking. So when we click an item, we want to know if it's the object we want to move from or the object we want to move to. So if clicked get component slot dot is empty, and notice that I made this exclamation mark here. So if that object we just clicked isn't empty, well, then it's occupied by an item, and we need to use this item to something. So this item can be moved around or do whatever it wants to. So when we enter this if statement here, we know for sure that we actually clicked an item we can move around. So from equals click that get component slot. So now we saved the reference to the slot we just clicked. Besides that, we also want to change the color of the slot we just clicked, because when we click a slot, we want to indicate where we're moving something from. So from that get component image And if you can't see this image, if it doesn't, if you get this squishy red line, then right click on it, click resolve, and click using Unity Engine UI. You can go up here and see Unity Engine.ui is added up here, and if you don't have Visual Studio, then as usual, go up here and write Unity Engine.ui. So image.color equals color.gray, not green. There we go. So now the item I'm clicking should actually be grayed out. Okay, so if from isn't null, well then we already clicked one object and we need to select the object we want to move it to. So else if 2 equals null, well then 2 equals clicked that get component slot. So then we selected our 2 object. So if 2 isn't equal to null and from isn't equal to null, well then we need to swap the 2 items because we already selected our from, and next time we click we check, yeah, well, is it possible, is 2 null? If it's null, well then we're gonna move our item up there. And then we say, well, if 2 null and is from null, not null, well, if they're both not null, well then we selected both items we want to swap around, so we can start swapping them. So stack items temp from equals new stack item 2 dot items. Okay, so I want to access the items on my my slot object. So I need to go to my slot class here, go to the top here and see that item here is private. So if I want to be able to access this, I need to right click on it, click refactor, encapsulate field, click OK. Again, if you don't have Visual Studio, you can write this code by yourself, writing public stack item and get return both of them and set items equals value. So when I've done this, I can go back into my inventory and write 2 dot items, this, and this shouldn't be temp from, it should be temp 2. Here we go. So now I just saved the items that is saved on the 2 slot, so that I can move them around, because now I'm gonna say 2 dot add items from dot items. So the reason that I saved my 2 items up here is because that I'm actually replacing my 2 items here with the from items, and so I don't overwrite the items that was originally stored on the 2 slot. Well, then I have to save them up here in a temporary stack. Okay, when I've done that, I need to check if temp2.count equals 0. And if the count equals 0, well, then I just need to clear the from icon, because if I move a stack to an empty slot, well, then there's no reason to swap anything. I can just clear the item I'm moving something from, or the slot I'm moving something from. And to do that, we need to add a new function to our slot class. So go to the slot class and then go to the bottom of it, and then write public void clear slot. So this function is basically just gonna clear the slot from anything that's on it. So we're gonna write items that clear, and we're gonna change the sprite to slot empty and slot highlight. So we reset the sprites to the standard, and text equals string.empty. So this function is basically just going to clear the slot if we have a stack of mana potions and we click on it and place it on an empty slot. Well, then the slot we moved it from needs to be reset. So that's basically what we're going to do here. So inside our inventory, again, we're going to say from, if the temp2 count is 0, then it's empty, dot clear slot. So now it has been cleared. So else if the slot we're moving to isn't empty, well then we need to swap them. So from dot add items temp2. There we go. And that is exactly why we stored a reference to those 2 items, because they have been replaced here, and now we just use the reference to replace the from slot. So then we're going to go down here and say from that get component image, and the color is going to be reset to color.white. And if we don't do this, then the item is still, or the slot is still going to be look like it's taken, like it's occupied, because we want to reset the color to white so it doesn't look grayed out anymore. That's exactly what we're doing. So to equals null and from equals null. Because now we're done selecting, we have swapped the 2 items, and to and from isn't supposed to be have a value anymore, because we don't have to move anything around. So next time we click on an item, well then to and from is 0, is null again, and we can figure out how to select one of them and swap them around one more time. So this is basically just resetting them. Gonna save that. So now this should actually work, so let's go in Unity and give it a shot. We need to set up a few things. As you can see here, there is like an on-click event here, and that on-click is actually run every time I click on these items out here. So this on-click event needs to be added. So we add plus here, and then we need to add an object. And to add this object, we need to create a prefab of our inventory. So go to your hierarchy and drag the inventory to the prefab folder. Click on your slot, drag the inventory from the folder to this place, and now we need to find the inventory script on this inventory we have here. So on the function list here, you click, go to the inventory script, and then you find the move item function. And when you found that function, well then you just need to drag the slot from here to this one, because we need to tell it what slot it clicked. And when you click a slot, well then it's that slot that is involved. So if we run it now, you'll see, oh sorry, don't want to have maximize on. If we run it again, then you'll see that each slot actually has a on-click event on it, and it's also linked to the inventory move item and the slot itself. So let's try to pick up some items. Now I actually want to have it maximized so we can see what's happening here. So we should pick up a couple of items here. Then I want to swap the blue and the red one. I click the blue one, it goes out as we wanted to, and it swaps around with the red. Click the red one, swap those two, there's nothing happening. And if I click this one and click an empty slot, then you can see that it actually just occupies the empty slot here. So now we can actually move our items around, but we want to add 2 more things. We want to be able to, when we click a potion, well then we want a hover icon to follow the mouse around so we can see what we selected and where we want to place it. And we also want to be able to click on an icon or an inventory item and click out here outside the inventory to delete the item. So we have basic inventory functionality now, but we want to add two more things. So to do that, we need to jump back into our script. Okay, I have a quick side note here. If you have this problem where you click on a slot in your inventory and it keeps being selected and it moves around whenever you move your character around, well, then it's because you need to disable the navigation on your slots. So if you go to your slot prefab here, select it in your folder, and then click navigation and click none, well, then there's no navigation on your buttons, because all buttons has this navigation set to automatic as standard, and that's basically the normal navigation in the menu. So whenever you press any arrow keys or something, well, then it navigates between the buttons. So now when this is disabled or set to none, well, then I don't have these crazy movements in my inventory anymore, as you can see, and I don't select any of the inventory slots alone. Yes, that was just a quick side note. Back to the tutorial. So the next thing I want to add is the icon that hovers next to the mouse whenever you click a stack of items you want to move. And to do that, we need to add 2 more fields. So we need to create a public game object called icon prefab. And this prefab is basically just going to be the prefab we use to instantiate that icon that follows the mouse around. And then we need to create the object itself that we're going to move around in the game world. So private game object. Let's make static private static game object. Call it hover object. So when we've done that, we need to move to our move item function, and we need to instantiate this object next to the mouse inside the from if statement here, because whenever we click a new item, the first item we click is the item that is going to hover next to the mouse. So our hover object is going to be equal to instantiate icon prefab, and we need to cast this into a game object, else we're going to have an error. Okay. So now we have casted our prefab into the hover object that we need to move around. Then we need to change the image of the object to the correct image. So if we click a mana potion, of course we need to hover a mana potion next to the mouse. So hover object.getComponent image that sprite equals clicked that get component image that sprite. So we take the sprite from the component we click, or the slot we clicked, and we add it to the hover object. We also want to change the name, so hover object.name equals hover. So the next thing we're going to do is to make a reference to the rect transform of the hover object and a reference to the rect transform of the clicked object. So let's create a rect transform, hover transform equals hover object get component rect transform clicked transform equals clicked that get component rect transform. Okay. So now we have stored the transforms, and the next thing we need to do is to use them, because we need to make sure that the hover object has the same size as the object we just clicked, because if the slot is big, then the hover object needs to have the same size. For example, if it's small, then the hover object needs to be a little smaller, so it looks like you actually take the slot out and move it to another place. So we're gonna say hover transform dot set size with from parent edge, no, hover transform dot set size with current anchors, that's it, and we're gonna give it the rect transform dot axis dot horizontal as the first one, and it's gonna be equal to the click transform dot size delta dot x. So that's the horizontal one, and then we're gonna do exactly the same just for the vertical one instead, and then y. So now we have set the size of the rect transforms. The next thing we need to do is to make sure that our hover object is a child of the canvas, so that it's visible on the screen. So we need to say hover object, hover object the transform that set parent, and the parent should be game object that find canvas, because our canvas should have that name, the transform, and then it asks will position stay, just true. So here we just made sure that the hover object is a child of that canvas. And then we need to make sure the local scale is correct, so we need to say hover object transform that local scale equals from dot game object dot transform dot local scale. Here we could actually also have said clicked, but anyway. So here we make sure that the local scale is correct. So after we have set the rect transform size, then we also set the normal transform size so that everything fits. So now we have made sure that we instantiate our icon, but we're not moving it around yet. One more thing that's very important for this is that we need to go to the bottom of the move item function and make sure that hover object is null when we're done moving stuff around. Because we're going to go to our update here, and in our update we're going to check up on if hover object exists. So if hover object isn't equal to null, well, then we need to move the hover object around in here. If we would try to move it around when it's not instantiated, well, then we're just wasting our resources. So there's no point in moving something around that doesn't exist. So that's why I always check if it's null before I try to move it here. Okay, so to move it around, we need to know the canvas and we need to know the position on the canvas. So I'm gonna make a little reference here called public canvas, so that I have a reference to our canvas that this inventory is sitting on. And then I need to make a vector2 position, and this should be the position that we're gonna move the icon to all the time. And then I'm gonna make a rect transform utility dot screen point rectangle, and basically this function basically transforms the screen space point into a position in a local space of a rect transform. So we basically take our on-screen coordinates and transform them into a position inside our canvas, so that we can make that icon follow the mouse around. So the first parameter here, it's gonna ask for a rect transform, and that transform we are gonna give it here is that transform to find a point inside, and that's exactly our canvas as rect transform. So then we have given it the canvas. The next thing is the screen point, and that's basically the point where we want to translate. So our screen point is basically our mouse position, or what should I say? So that should be input that mouse position. There we go. The camera, well, the camera is the camera that is associated with the screen space position, and that's the camera that is associated with the canvas. So that would be canvas dot temp world camera, I think it's called dot world camera, sorry, canvas dot world camera, yeah. And then we need to tell it where it needs to store this translation of position, so it's out in position. So all this is actually stored in our position here. Sorry. Oh, sorry, I need to take canvas.transform here. There we go. So when we've done that, well, then we need to actually move our object, and we can do that by saying hover object the transform that position equals position, canvas the transform from point, transform point, and then give it the position. There we go. So basically this code makes the hover object follow the mouse around on the screen. So let's save this, and then we can jump back into Unity. Okay, so the next thing we need to do is to make sure that our inventory is getting those two objects that we just made it request. So our inventory script here, if you select your inventory in your hierarchy, well, then you'll see that it requests an icon prefab and a canvas. And the canvas is very easy to get. You can just take the canvas up here and drag it onto the slot here. Next thing we need to do is to create a icon prefab. And the icon prefab is what we need to use to create that hover icon next to the mouse. So the hover icon is basically, or the icon prefab is basically going to be the same as the slot here. with a few exceptions. It doesn't need the button script, and it doesn't need the slot script, and it doesn't need the text of stacks. So we need to modify this. So drag it onto your hierarchy, click on it to open the stacks, and delete the stacks. When you've done that, select it again and go to your inspector out here, and then right click on the button script and click remove component, and do the same for the slot script. So now you have created a icon prefab, so just click on it, press F2, and rename it to icon prefab. When you've done that, drag it into your folder again, and you have created your icon prefab. The icon prefab inside the scene can just be deleted. So your inventory also needs this prefab, so take it and drag it from your prefab folder onto the inventory prefab, like this. So now you have added the prefab. So if you play your game and pick up some items, then you should be able to pick up one of these items by clicking on it. And as you can see, I already picked up the mana potion, and it's following my mouse wherever I go. So if you notice that you can't place it, as you see here, it's very hard for me to place it anywhere. Well, then it's because there is a few things we need to fix. And as you can see, the hover icon here stays whenever I place it. If I manage to place something, well, then the hover icon is not removed. So we need to do two things. We need to make it easier for us to pick up an item and place it somewhere. And we need to make sure that the hover icon is removed whenever we place an item in our inventory. So to do that, we need to go back to our script here. So the actual reason that we are unable to place these icons or place the items very easily is because the hover icon is actually covering the mouse. So we can't really place it on the inventory because the hover icon is in the way from the click. So we need to move the hover icon a little bit, tiny bit down, so it's easier for us to click with the mouse. And to do that, we actually simply just need to make a offset. So we're going to make a float, private float, and call it hover y offset. So basically this offset just needs to be very, very little. And I'm just going to make it as it's the slot size 1% of the slot size. So we're going to make the hover icon, move 1% of the size of the slot down. And we can do that in our create layout. And our hover offset is basically just going to be equal to the slot size multiplied by 0.101. So we get 1% of the slot size, and we add that to our y offset. So this y offset is going to be added to the position of our hover object. So if we say position set, and it should be the same as position.x is fine. Position.y should be position.y minus the hover offset. So now we just change the position a little around, so the y position is a little different. So if we save now, go back into Unity and run it again, you'll notice that it's way easier to place the icons now. See, now it places it every single time. But we still have this problem where the hover icon stays whenever we just place an item. So to fix this, we need to get back into the script again. And we then need to what's called destroy that hover icon. So if we go down here, see if I can find move item here. When we do this, when we place it on another icon, that's basically what happens here. Well, then we need to destroy GameObject.find, and we called it hover here. So this line of code makes sure that the game object doesn't stay on the screen anymore. So let's go back into Unity. and run it again. There you'll see that the icons actually gets destroyed when you have placed it somewhere. Okay, so the last thing I want to be able to do is to delete an object. So if I take this object and click outside here, I want it to be deleted. So we need to add that one last functionality before we're done with this. So if we want to make it possible to delete an item by picking it up and clicking outside the inventory, well, then we need to distinguish between clicks inside and outside the inventory. And we can do that by using the event system. And the event system is automatically added whenever you add a UI element for the first time in your scene. And basically the event system is something that keeps track of all kinds of events like button clicks and stuff. To use this event system, we need to create a reference inside our inventory. So if you go to your inventory and jump to your fields up here, then you should create a public event system called event system. And this event system should just be assigned from your inspector. So if you jump back into Unity and click on your inventory, you'll see this new spot here. You can just take your event system and drag it there. So when you've done that, we can start writing our code in our update. First of all, I want to check if I click one of my mouse buttons before I use the event system. So if input.get mouse button down, now I want to do up, get mouse button up, 0 because I want my left mouse button that has index 0 here. Then I want to check if my event system dot is pointer over game object, and the pointer I'm going to look for is the mouse pointer, and that has index -1 for some reason in this this event system. So, and I want to make it negative, so I'm going to make an exclamation mark in front here to make sure that it's opposite. So I'm checking if my pointer isn't over a game object and I let go of mouse 1. Well, then I need to check if I want to delete an item. So this alone isn't enough. I also want to check up on if my from is different from null. So if my from isn't null, well, then I have picked up an item, and if I click somewhere that there isn't an inventory, well, then I'm going to delete it. So here I need to delete it. My from field that get component that image, well, needs to be turned back into white color. So I'm going to set the color to white. And then I'm going to say from that clear slot, because I also want to clear the slot, because if I delete the item, well, then I also need to clear that slot it was sitting in. And then I'm going to destroy my game object, find hover, because I don't need that hover object maybe more because I deleted it. And then 2 is going to be null, because I want to reset. From is going to be null, also resetting that. And hover object is also going to be null, because I'm also resetting that. One more thing we need to change to make sure that we can reach our from up here, so it's not we don't get any complication. That is that we have to go to our private slot from and to, and we have to change this private to static, because sometimes there can be some complications when you instantiate or set the values inside methods that are called by buttons. So just to make sure that we don't get any mistakes or any errors, just make this one static. Then you have to save and go back into your game. Then we should try to run it. Let's see if we can pick up some items here. And as you can see, I'm able to delete my items by picking them up and clicking outside the inventory, and I can still move them around. And that's basically it. So thank you very much for watching, and if you have any comments or suggestions, please leave them in the comment section. I've linked the video to my link to my video about the health bar tutorial in the video description. And if you want to support me, then please buy the project and download it with all the sprites and everything. That's it.